Okay, finite math students. Hey, how are you? It is Sunday and let's see, it's March 28th, 2:45 in the afternoon. Um, I've got to take my dog outside soon, so hopefully this video won't be longer than an hour. What I or an hour, an hour and a few minutes. Okay, let's see how things go. I just assigned your quiz on matrices and systems of equations. And we're going to go over the quiz. Oh, and obviously, now please remember, your questions are going to be slightly different from the questions that you see in this video. You know, your numbers will be a little bit different. The questions should be very similar, but the details, the numbers will be a little bit different. And I hope you know that. So you can't just copy my answers, because if you do that, you're probably going to get a 0 on the quiz. So that's not smart, okay? So this quiz, okay, hold on, where's your quiz? Okay, so your quiz is here. Let's go over this. Okay, so here, one second. Let me get a little bit organized. I'm kind of rushing today, so that's not the best way to teach necessarily, but you know, we do what we got to do, right? So you know what? One second. Let me turn on my marker. Where's my marker app? My marker app is right here. Okay. That marker app is great. It lets me do stuff like this, right? Yeah, okay. Every teacher should have a marker app, especially if you're teaching from home, like, you know, we have to do right now, right? Okay, so, okay, here's your quiz. And let me kind of shrink this down a little bit. Okay, let me move this window over. Okay, so question 1, write the solution of the linear system corresponding to the reduced augmented matrix. Well, this is really easy. I mean, this is really, really easy. Question 1, you know, everyone should be able to do this. You don't need a calculator, you don't need Mathematica, you just need some common sense. So this, excuse me, this matrix is already reduced. This matrix is already in reduced form, which makes things very convenient. Okay, so there's not a whole lot going on here. So the unique solution is simply going to be -7, 5, and 0. Your input is correct, score 100%. Okay, terrific. Let's move on to the next problem. That's easy. Now, a word of warning, not all the problems are easy. Some of the problems are more challenging, okay? So this was a very easy problem. Okay. So this problem is going to be a little more difficult. Hold on one second. Let me get a drink of water here. Okay. Okay. This problem's a little bit more challenging. So I can see here that I have a row of zeros at the bottom. I have a row of zeros at the bottom. That tells me that I have infinitely many solutions. Excuse me. This problem, this system of equations has infinitely many solutions. How do I know that? Because I have a row of zeros at the bottom. Excuse me. I have a row of zeros at the bottom. So let's see. I know that the correct option is B. The system has infinitely many solutions. Now, how am I supposed to figure out, the rest of the answer? Okay, so look at the equations, right? So this is going to be x1, this is x2, this is x3. Here's my equal sign, and then I see a bunch of numbers. Yes? Okay, so look at the first equation. So I see x1, there's no x2 because I see the 0 there, minus 3x3 is equal to 4. And then I go to the next equation and I see, okay, x2, there's no x1 because of that 0, right? x2 plus x3 is equal to -8. And then I just see a bunch of zeros here. Of course, that's just, 0 is equal to 0, which, okay, duh, that's always going to be true. 0 is always equal to itself. Any number is always equal to itself, right? That's not rocket science, okay? So here, right over here, they're saying, okay, hold on one second. The vacuum cleaner is in the background, and we don't want that. So I'm going to have to put this on pause one moment. Okay, so the vacuum cleaner stopped. Hooray. Okay. So this is what we have, okay? This is what we have. We have x3 is now equal to t. x3 is equal to t, and you could set it equal to anything. You don't even have to change it to t. You could leave it as x3 if you really want to, but in your book, they want you to change it to t, okay? So x1 minus 3t is equal to 4. Okay. And then you have x2 plus t is equal to -8. And of course, t is always going to be equal to t. All right. Well, x3 is equal to t, and that's what they're telling you right there. So that means, hold on one second. So that simply means x2 has to be -8 minus t. Just basic algebra right here. And then x1 has to be 4 plus 3t. And that should be correct. Your input is correct, score 100%, okay? So that really shouldn't be too difficult, okay? That shouldn't be too difficult. Okay, now my dog is barking up a storm. Okay, Chachki, please stop. Okay, it's either the vacuum cleaner or the dog, Okay, great. Okay, so we're going to try to make this work. Okay, so we already checked the answer here. The answer is correct. Okay, write the solution of the linear system corresponding... Okay, Chachki, enough. Write the solution of the linear system corresponding to the reduced augmented matrix. Now, the problem here... if you look at the bottom row, well, if you look at the bottom row, you have 0 times x plus 0 times y is equal to 7, and that makes absolutely no sense. Because over here you have x is equal to 2, right? And then here you have y is equal to 8. Okay? Well, 0 times 2 plus 0 times 8, is that supposed to be 7? No, it's supposed to be 0. This number here should be 0. That number should really be 0, which means you have an inconsistent system. It doesn't make any sense. It makes no sense, which means there is no solution. There is no solution. Your input is correct. Score 100%. Chachki, we'll go outside a little later. Now stop. Your input is correct. Score 100%. I'm just talking to my dog, guys. Okay. He's going to have to wait. Okay, so... Okay, the next problem, number 4, write the solution of the linear system corresponding to the reduced augmented matrix. All right, so here, again, you have to use some common sense, guys, okay? So we have, well, I think they're using x1, x2, x3. Okay, so we have x1 minus 7x3 is equal to 6. And then we have x2 plus, I'm just looking at the matrix, I'm looking at the rows of the matrix, x2 plus 5x3 is equal to -2, okay? And what they want to do, I'm sure they're going to replace x3 with t, all right? I know they're going to replace x3 with t. We know that from the previous questions in the quiz, okay? So we're going to have x1 minus 7t is equal to 6. And then we have x2 plus 5t is equal to -2. Okay, so this is what we're going to have. So we have x3 is just going to be equal to some number t, right? And then we have x2 is going to be equal to -2 minus 5t, and that's just simple high school algebra. That's freshman algebra from high school, right? That's no big deal. And then x1 is equal to 6 plus 7t. So then, because t could be any number, you don't know what t is. T could be any number. You have infinitely many solutions, okay? So then, let me see here. The system has infinitely many solutions. The solution is x1 is equal to 7t plus 6, or 6 plus 7t, it doesn't matter because addition is commutative, right? 2 plus 4 is the same as 4 plus 2. And then this is going to be -5t minus 2, and x3 is equal to t. Your input is correct. Your input is correct, score 100%, okay? So these problems really should not be too bad. I mean, I don't think they're that dreadful, okay? Use row operations to change the matrix to reduced form. Okay, 1 second. Let me get rid of that. Okay. Use row operations to change the matrix to reduced form. Well, the bottom row is already reduced. There's not, there's nothing really to do. We know this is going to have to be a 0, right? So what is this number going to have to be? Okay, well now think about it. I'm actually going to try this without Mathematica because it's really not a hard problem. Okay, so in order to change the 3 to a 0, what do we have to do? So it's going to be row 1, the new row 1 is equal to row 1 minus 3 times row 2. Okay, so you're going to have 1 minus 3 times 0, and, well, you know, that's just 1. And then you're going to have, let me see, you're going to have this number 3 minus 3 times 1, and that's this 0 right over here, right? And then you're going to have 1 minus 3 times 4, and that's 1 minus 12, which is negative 11. Okay? So that means this number here should be negative 11. Your input is correct, score 100%. Okay? That wasn't so hard. I mean, we could have done that with Mathematica, right? But it's a pretty easy problem. You don't really need Mathematica to do this problem. I mean, you could use Mathematica, but it's not necessary because it's a pretty simple problem. Okay. Check answer. Your input is correct. Score 100%. Okay. Number 6. Use row operations to change the matrix to reduced form. Now, this is a little bit more complicated, so yeah, I'm going to use Mathematica. All right, I'm going to use Mathematica because this is not quite as simple as the previous problem. Okay. So matrix is equal to 1, 1, 1, 17, and then 3, 4, 9, 22. Matrix form, shift enter. Okay, terrific. So this has to become a 0, right? That 3 has to become a 0. So how do I do it? So matrix, row 2 of the matrix is equal to row 2 of the matrix minus 3 times the first row. The first row. Okay. So now we have 1, 0. Okay, so 1, 0, that first column is finished. Terrific, yay. So now we have to have a 1 here, right? We have to have a 1 here, you know, in the second row, second column. There's already a 1, so that's really easy, right? So I'm going to change the top row, the first row, because this value has to become a 0, right? It has to become a 0. So how am I going to do that? So you're manipulating the entire first row, the first row minus the second row, and let's see what it looks like. Okay, that's as far as we can go. That's as far as we can go. Because we only have 2 rows. We only have 2 rows, so the row operations only apply to the first 2 columns. So that means that this matrix is equivalent to 1, 0, negative 5, 46, 0, 1, 6, negative 29. Okay? Your input is correct, score 100%. Okay? So, not hard to do. You just have to know how to manipulate the rows of your matrix in Mathematica, right? Okay, let's move on to the next problem. Use row operations to change the matrix to reduced form. So it's the same thing, you know, just like what we did for number 6. Should be easy. Let me just move this over. Okay, so clear matrix. Okay, I have a new matrix now. Matrix is equal to 1, 0, negative 4, 1, 0, 1. Actually, you know what? I'm looking at this matrix. Okay, you know what? I'm making this problem too difficult. Actually, it's already in reduced form. This matrix is, well, technically, no. Technically, okay, hold on one second. This number right over here, this has to be a 1. And, okay, so actually, it's not in reduced form. Sorry, okay. It's almost in reduced form, but not quite. So matrix is equal to 1, 0, negative 4, 1, 0, 1, 3, 0, and then 0, 0, 2, negative 6. Matrix form. Okay, so the first two columns look good. These two columns look fantastic, right? Excuse me. However, the third column needs to be reduced. The third column needs to be reduced, which means what I'm really looking for is a matrix that looks like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. And then these are going to be numbers. You know, this is going to be, you know, x1, x2, x3. Those are going to be numbers, okay? So we have to decide, you know, what are those numbers, right? Okay, so this should be pretty easy. So the 2 has to become a 1. How do you change it into a 1? You multiply the entire third row by the reciprocal of 2, which is 1/2. All right, so matrix third row is equal to 1/2 times the third row of the matrix. And matrix form, okay, we're good. And then the first row, we want this to be a 0, right? That has to be a 0. And that has to be a 0, right? So how do we do that? So matrix first row is equal to matrix first row plus 4 times matrix third row. And how do we do that? Okay, that's simple. And then finally, that little 3 has to get changed into 0. So how do you do it? You're going to take row 2 minus 3 times row 3. You're always going to refer back to the row that contains that magic 1. You're always going to have to refer back to the row that contains that magical 1, okay? So that's really important. So I'm changing the second row by taking the second row, minus 3 times the third row. And why am I doing that? Because 3 minus 3 times 1 is 0, okay? Matrix form. Okay, so now the matrix is in reduced form. Okay, so we're going to have 1, 0, 0, and then we have 0, 1, 0, and then we have 0, 0, 1, and then we have negative 11, 9, and then, excuse me, negative 3. Check answer. Your input is correct. Score 100%. Yay, terrific. Easy. I mean, these problems should not be that difficult, guys, and you really need to know how to do this for the next chapter. For the next chapter, we really must understand how to do this stuff. All right, super, super important, okay? Let's go on to number 8. So we're almost finished. Okay, use Gaussian elimination to find the complete solution to the following system of equations or show that none exists. Okay, same thing as before. I mean, this should be pretty easy. Okay, so now I'm going to call it matrix A. We have 7, 23, 4, 14. 3, 10, 3, negative 8, and 1, 3, negative 2, 6. So let's see, 7, 23, 4, 14, 3, 10, 3, negative 8, 1, 3, negative 2, 6. Looks good. Now, guys, I'm going to kind of rush through this a little bit because, I don't want this video to go on and on and on forever and ever, and my dog is waiting for me. So I want this to be a 1, so why don't I just swap the first and third rows? Okay, so I'm going to swap the first and third rows. I think this is how you do it. Hope I don't mess this up. Okay. Right, so I just switched the first and third rows. Okay, easy. So I have a 1 up here in the upper left. So now let's change the second row. It's going to be minus 3 times that first row, because 3 minus 3 times 1 is 0, right? So then we have 1, 0, okay. And we're going to do the same thing with the third row. So the third row minus 7 times the first row, because the first row has the 1 in it. And there we go. Okay. Now there's already a 1 here in the second row, second column, which is good. So this has to be a 0. That has to be a 0. Okay, so let's change those values. So I'm manipulating the first row, and that's going to be minus 3 times the second row. And I'm referring back to the second row because the second row is the row that has that 1, okay? It's the row that has the 1. So let me, there we go. So the first row of A minus 3 times, the second row of A, and then A matrix form. Looks good. And then the third row, it's going to be the third row minus 2 times the second row. And that's going to be, okay, so because there's a 0 here, okay, you really expect this to be a 1, right? But because it's a 0, we know there's no solution. We know there's no solution because in order to change this number into a 1, I would have to multiply the third row by the reciprocal of 0, but there is no reciprocal of 0. So remember, in order to change this number into a 1, right, you have to multiply every number in the third row by the reciprocal of this number right here. But there is no reciprocal of 0. 1 divided by 0 doesn't really exist. It's undefined. So therefore, let me just, hold on one second. Therefore, this problem has no solution. It's an inconsistent system. It's an inconsistent system. Your input is correct, score 100%. Okay, let's move on to question number 9. Solve using Gauss-Jordan elimination. Okay, same thing. So this time I'm going to call it matrix B. So B is equal to 4, 8, negative 28, 20, and then 3, 2, negative 9, 3, 1, 1, negative 4, 2, B matrix form. Let me make sure the numbers are correct. So 4, 8, negative 28, 20, 3, 2, negative 9, 3, 1, 1, negative 4, 2. So my matrix looks good. Okay, same as before. This is very similar to what we did for the previous problem, okay? So, hold on guys, let me just take a sip of water here. Hold on. Okay, I get a sore throat if I just keep talking and talking and talking, so the water is very helpful. Okay, so we're going to swap the first and third rows, and the reason I'm doing that is because I want this number here to be a 1. I want the number in the upper left of the matrix to be a 1. So we're going to swap the first and the third rows. Matrix form, okay. And I'm going to start picking up the speed a little bit, guys. I'm going to go through these problems a little bit faster because, you know, my dog is waiting for me to take him outside. So I'm going to kind of step on the gas pedal and go through these problems a little faster. So let's change the second row. The second row is going to be, the new second row is equal to the old second row minus 3 times the first row. And then, oh, what am I doing? That should be that should be a B. Sorry about that. And B matrix form. Okay. And then I'm going to manipulate the third row. The third row is going to be the third row. The new third row is equal to the old third row minus 4 times the first row. And let's see, matrix form. Okay. Now this has to get changed into, hold on one second. This number here has to get changed into a positive 1. How do you change -1 into a positive 1? Well, you simply multiply the entire row by -1. That's it. Okay, so then the, oops. Matrix form. Okay, there we go. Okay, so we're going to multiply the entire second row by -1, right? We're going to go outside soon, Chachki. Just be patient. Matrix form. Okay. And then this number here has to be 0, and this number here has to be 0. Right? Okay. So then the first row is equal to the first row minus the second row. Matrix form, okay. And then the third row is equal to the new third row is equal to the old third row minus 4 times the second row. Okay, so here, are you playing with your bear? Okay, I'm talking to my dog, guys. I'm not talking to, this is not math. I'm talking to my dog. 1 second. Okay, Chachki will go outside soon. You have to wait. All right, guys, I'm gonna have to take my dog outside soon, I think. So we'll have to wrap it up in like 10 or 15 minutes. Now you can see there's a bottom row of zeros here. All right, look at that bottom row of zeros, and that tells me a whole lot, because what that tells me is 0 times x1 plus 0 times x2 plus 0 times x3, well, that's going to be equal to 0 for any combination of values of x1, x2, and x3. So x1, x2, and x3 are not going to be unique values. They're not going to be unique. All right? So then what we have is really going to be x3 is equal to t. x3 is equal to some parameter t, right? And then look at the first equation. x1 is going to be equal to -1 plus t. Okay, remember, this is an equal sign right over here. And then x2 is equal to 3 plus 3t. Now, those are the answers. Those are actually going to be the answers. So let me see here. The system has infinitely many solutions. The system has infinitely many solutions. The solution is x1 is t minus 1, or negative 1 plus t is the same thing. x2 is 3t plus 3, and x3 is t. Your input is, your input is correct, score 100%. Your input is correct, score 100%. Okay, so hopefully you guys understand how to do that. All right, like I said, you know, these problems are important, okay? Because if you don't know how to manipulate the rows of your matrix, then you're really going to have issues in the next chapter. You just won't be able to do the next chapter. So you have to understand how to manipulate the rows of your matrix, because otherwise the next chapter is just, it's going to be impossible to do, okay? So we already checked this. This looks good. We have problem 10 and problem 11, and then we're done. Okay, so this is a pretty big matrix, but you know, let's do it. Okay, so I'm gonna call this one, I can't call it C or D. Those are reserved variable names in Mathematica. So I'm gonna call it Mat. Excuse me, Mat is short for matrix. I'm just gonna call it Mat, short for matrix. So 1, -1, 2, -1, 0, and then -3, 5, -5, 0, 1.9, and then we have 2, 0, 9, -8, 4.2, and then we have 3, -2, 3, 2, -3. Matrix form. Okay, so let's make sure the numbers are okay. If you make a mistake entering your numbers, guys, you know the answer is definitely going to be wrong, right? So let's see, 1, -1, 2, -1, 0, -3, 5, -5, 0, 1.9, 2, 0, 9, -8, 4.2, and then we have 3, -2, 3, and then we have 2, and finally -3. So it looks okay. Okay, so we already have a 1 here in the upper left corner. That looks great. Matrix 2, the second row of matrix 2, okay. So that's going to be plus 3 times that first row. And what does that look like? Okay, and let's change the third row. The third row of the matrix is going to be the third row of the matrix minus 2 times the first row of the matrix. Let me make sure. Hold on one second. Yeah, we're fine. Let's see. So that's the result. And that 3 has to get changed into a 0. So we're changing the fourth row of the matrix. So the new fourth row is going to be the old fourth row minus 3 times the first row. And let's see what that looks like. Okay, fantastic. Now, this number here, this value here has to get changed into a 1. That has to get changed into a 1. So how are we going to do that? Okay, so the second row is equal to 1/2, just multiplied by the reciprocal times the second row, and then we have matrix form. Looks terrific. The first row is equal to the first, the first row, the new first row is equal to the old first row minus, yeah, so okay, I have to concentrate on this. So the new first row of my matrix is equal to the old first row minus the second row. So this won't change, guys. This is still going to be 1. Why? Because what is 1 minus 0? 1 minus 0 is still going to be 1. 1 minus 0 is still going to give you 1. So that number isn't going to change. All right, so let's see. So the first row minus the second row, oh, actually plus. It's going to be plus. Why is it plus? Because negative 1 plus 1 is equal to 0. So it's actually going to be plus. Okay, and then of course 1 plus 0 is 1, so that doesn't change anyway. So then we have matrix form. Okay, that looks good. And then the third row changes. So let's see, that's going to be minus 2 times the second row. And let's see what that looks like. Okay, so all we have left is this 1 here. So this is going to have to get changed into a 0. How do we do that? It's very easy. So it's the fourth row, right? The new fourth row is equal to the old fourth row. The new fourth row is equal to the old fourth row. The new fourth row is equal to the old fourth row minus the second row, because 1 minus 1 is equal to 0. So then we have matrix form. Okay, now we're getting there slowly but surely. This has to become a 1. Okay, so the 4 that you see here in the third row has to become a 1. So we're going to multiply the third row by 1 over 4 times the third row. And what does that look like? That looks like that. Okay, so far everything looks pretty good. Now here we do have some round off error happening. Don't worry about it. It's okay for now. And then the second row is equal to the second row. Let's see. Minus 1/2 times the third row. Okay, that looks good. So we're going to end up, because we're not using exact fractions, because we're using decimal approximations, there is going to be round off error going on in the last column. All right, so right over here, because we're not using exact fractions, we're using decimal approximations, there's going to be round off error in the last column. But for right now, don't worry about it. It's not that much of an issue. Okay. Let's see. So then the first row is going to be, the new first row is going to be equal to the old first row, right? Minus 5/2 times the third row. Okay. And then finally, well, it's not really finally, for this column, okay, this number here has to be 0. So the fourth row is going to be, the new fourth row is equal to the old fourth row plus 7/2 times the third row. Okay, and then finally, we have to work on this column over here. So this has to become a 1. How do you change 31/8 into a 1? You have to multiply by 8 over 31, which is the reciprocal of 31 over 8. So then the fourth row is equal to 8 divided by 31 times the fourth row. Okay, that looks great. And then let's work on the third row, the second row, and then the first row. The third row, the new third row, is equal to the old third row plus 3/4 times the fourth row. Okay, so the new third row is equal to the old third row plus 3/4 times the fourth row. Okay. And then the second row, the new second row, is equal to the old second row plus 9 over 8 times the fourth row. Okay, so then the new second row. Okay. The new. Hold on, there's noise going on in the background. So the new second row is equal to the old second row plus 9/8 times the fourth row of the matrix. Okay. Okay, so it's going to look like, the new matrix will look like that. All right. And then finally, we have the first row is the new first row is equal to the old first row plus 5/8 times the fourth row. Okay, so the new first row is equal to the old first row. This is the new first row is equal to the old first row plus 5/8 times the fourth row, which will cancel out the negative 5/8. And then we have this solution. So this is our solution. This is actually our solution. So let's see. Okay, so let's see what our answer is going to be. Okay, the unique solution is simplify your answers. Now, what really bothers me about this, it's actually, the problem here is the round off error. There's going to be round off error going on here. So answers to the question will be met. And actually, oh, wait a second. How am I going to do this? So all rows, and then I want the fifth column. Yeah, there we go. Okay, so all rows, fifth column, answers matrix form. Okay, now the problem here that kind of bothers me, we have decimal answers here. We have decimal answers. We have decimal answers, and it says simplify your answers, but we're going to have to round the answers. So Pearson may not like how we round the answers. So let's see. This is going to be negative 0.8 and 0.099999. We can round that out to 0.10. I'm going to add an extra 0 here for completeness. This should be 0.20, and this should be negative 0.50. So let's see. Yeah, that should be okay. It should be perfectly fine. So we have x1 should be equal to negative 0.80. And then x2 should be equal to 0.10. And x3 should be equal to 0.20. And x4 should be equal to negative 0.50. Now remember, I'm rounding these values out. I'm rounding these values out. Okay. So let's see. Okay, hold on one second. Let's see if Pearson likes my answers. Your input is correct. Score 100%. Okay, let's check. Your input is correct. Score 100%. Terrific. We have one more problem to do, and that's going to be it for today. Hold on one second. Let me just put this on pause for a moment. Okay, guys, we have one more problem to do, and then we're done. So let's see. Find A and B and C so that the graph of the quadratic equation y is equal to ax squared plus bx plus c passes through the 3 points. Excuse me. Point 1, we have negative 2, 13. Point 2, 1, negative 11. And point 3, 2, negative 11. What is the function? Okay, so again, this is this is an important problem. As business majors, you should be aware of how to do something like this, right? Okay, so what are we supposed to do here? So we have the function y is equal to ax squared plus bx plus c, okay? And in order to fit this function, in order to find a specific parabola, we need 3 points. Okay, we need 3 points. Why? Because we have 3 parameters here. We have A, we have B, and then we have C. We have 3 parameters, so we need 3 points in order to find a specific function, okay? So how are we supposed to do that? So we're going to have, let's use the first point. Y is 13. 13 is equal to A times negative 2 squared plus B times negative 2 plus C. Okay, so that's our first equation. That's actually going to be our first equation. And our second equation is going to be negative 11 is equal to A times 1 squared, okay, plus B times 1 plus C. And then the third equation is going to be, let me see here. That's also negative 11. Okay, negative 11 is equal to A times 2 squared, okay, and plus B times 2, and then plus C. Okay, so then we're going to have this matrix. We're going to actually have, I'm going to write it up here. We're going to have negative 2 squared is 4. 4 minus 2, 1. And then we're going to have 1, 1, 1. We're going to have 4, 2, 1. And then we have 13, 13, negative 11, negative 11. Okay, so this is going to be the matrix that we have to figure out. So the matrix, and I'm just using these equations right over here. These are the equations that I'm using right over here. Okay, so we have negative 2 squared is 4, right? 4, negative 2, 1, 13, 1, 1, 1, negative 11, 4, 2, 1, negative 11. So this is the first column corresponds to parameter A. The second column corresponds to parameter B. The third column corresponds to parameter C, excuse me, and these are the numbers. Well, here they're on the left side, but I put them on the right side. Traditionally, they're supposed to be on the right side, okay? It really doesn't make a big difference. So these numbers are from the left side of the equal sign, and here I'm simply putting them on the right side. Okay, so 13, negative 11, negative 11, okay? And that's it. So let me scroll down. So what should I call it? How about matx? Matx is equal to 4, negative 2, 1, 13, 1, 1, 1, negative 11, and then 4, 2, 1, negative 11. And let's see what that looks like. Matrix form. And let me make sure the numbers actually match. So 4, negative 2, 1, 13, 1, 1, 1, negative 11, 4, 2, 1, negative 11. Okay. So I can, oh, hold on one second. Okay. Okay. No vacuuming for a few minutes, please. Okay. So, yeah, okay, this is very difficult, guys. A lot of distractions. This is not a school, it's a home, but we'll just manage to do our best, okay? So I'm going to erase all of this stuff that I wrote using my marker. Let's erase it. And, okay, so okay, so let's see. So let's figure this out quickly. We have to swap the first and second rows of the matrix, right? So this is going to become the new row 1, right? So row 2 will become the new row 1, and then row 1 will become the new row 2. And the reason I'm doing that is because you always want the number in the upper left of the matrix to be the number 1. That has to be in the upper left of your table or matrix, okay? And that's why I'm switching the rows the way that I am, okay? So the way to do that then would be like this. In Mathematica, right? 1, 2, oops, square brackets, and then in using the curly Q braces, we have 2, 1. And what does that look like? Matrix form. Okay. So now let's manipulate the second and third rows. The second row, okay, second row minus 4 times the first row. So now we have a 0 below the 1, which is exactly what we wanted, right? Let's manipulate the third row of the matrix. So it's the third row, the new third row is equal to the old third row, and again, minus 4 times the first row. And what does that look like? Okay, so now we have 1, 0, 0. Terrific. So now we need to manipulate the second row. So the negative 6 here has to get changed into a 1, right? So that's going to be equal to negative 1 over 6 times the second row. And let's see, that looks good. That's a 1. Now remember, okay, the number above has to be 0, the number below has to be 0. And we have to use row manipulations in order to make that happen, okay? So it doesn't really matter which, I have to change the first and third rows. Do I want to change the first row first? Do I want to change the third row first? It's not important. That's your decision. It really, which one you do first or second, that's a matter of personal preference, okay? So I'm going to do the first row. I'm going to manipulate the first row. So that's going to be the first row minus the second row, because 1 minus 1 is 0, right? And let's see, so that looks good. And then I'm going to manipulate the third row. The new third row is the old third row plus 2 times the second row. Okay, so we're almost done. We're almost done with the problem. So remember, this has to be the number 1, and then after I change the negative 2 into a 1, then this number has to become 0, okay? So the third row is equal to negative 1/2 times the third row. Okay, and then the second row is equal to the second row minus 1/2 times the third row. So actually, now look at the top row, okay? Let me see here. The top row, you're going to have infinitely many answers, actually. So the top row, okay, according to the top row, you're going to end up with 0 times A plus 0 times B plus 0 times C is equal to 0, which means you're going to have many different possible solutions. Let me see here. So you know that B is going to have to be equal. B is going to have to be equal to -6. And C is going to have to be equal to -7. Oh, you know what? Okay. So actually then, this is, you know what? I think this is a linear function. They tricked you with this problem because A could be anything. A could actually be anything, but what if we choose A to be equal to 0? What if we simply choose A to be equal to 0? You know what? So let me see. If we have the function, okay, let's try this. Let's say A is equal to 0, which eliminates the x squared term. So then we have -6 times x minus 7. Okay. And let me move this window over. This problem's a little bit tricky. So then we have f of -2. Okay, so there is some, yeah, that's not correct at all. F of 1 is, no, this is not, okay, so this is not going to work. What happened? So this is not correct. I may have made a mistake. Hold on 1 second. Let me see here. Okay, let me go back to my setup of this problem because I think I may have made an error. So we have -2 squared, -2, 1, 13. We have 1 squared, 1, 1, -11. 2 squared is 4, and then we have 2, 1, -11. This actually should be okay. Very strange. Let me see what these points look like. There's something very strange here. Okay, something's very strange. So list plot. I'm tempted to just remove this problem from your quiz, actually. Because, yeah, this is not quite correct. Okay, hold on. Plot markers, filled circle, and 30 plot style is black, and image size is 600, and background is white. Yeah, this is, so these are the 3 points. You know, this problem, so yeah, that is really, really weird. So these are the 3 points. Negative 213 is up here. 1 negative 11 is here, and then 2 negative 11 is over here. That is really weird. That is really, really weird that I'm getting this as an answer. So you know what I'm going to do? Let me try, I'm going to cheat a little bit. Let me use linear model fit. Negative 213, 1, negative 11, 2, negative 11. And my variable, okay, well, my model is going to be A. Well, let me see something very, this would be nonlinear model fit, actually. Nonlinear model fit. So this would be A times x squared plus B times x plus C. My parameters are A, B, and C. My variable is x. Okay, this is not... Okay, hold on one second. Let me look this up. Non-linear model fit. Oh, okay, sorry, I misspelled that. Okay, let's try this one more time. Okay, let me erase. Okay, hold on one second. Let me erase this. Yeah, this problem is giving me a headache, but we'll figure it out. So non-linear model fit, negative 213, 1 negative 11, 2 negative 11. It has this form, B times x plus C. A and B and C are my parameters. X is my variable. There we go. Okay, so this is actually, I'm cheating a little bit for this problem. I'm using, because for some reason the matrix that I set up for this problem didn't work. I don't know why. I must have, maybe I made a mistake, but what I'm going to do, I'm simply going to use the built-in function nonlinear model fit. Okay, so, and I'm going to save my answer in a variable called problem number 11, nonlinear model fit, negative 213, 1 negative 11, 2 negative 11. A times x squared plus B times x plus C is the form of my function. My parameters are A, B, and C, and my variable is x. So problem 11, is it best fits? Well, actually properties. I think it's properties. Oh, no, that's not what I want. Hold on one second. properties. No, wait a minute. That's not what I want. Hold on a second. Problem 11x. Well, okay, this is good enough for now. It's good enough for now. So I think there's a way to problem 11. Let me see. Is it properties? Yeah, there we go. Properties in double quotation marks. Table form. Okay, so best fit. Best fit. Best fit. Or you know what, we could just do this. Problem 11x. Okay. So that is going to be finally 2x squared plus 6x minus 7. And you know, I should have gotten those same answers from my matrix, which means I think I made a mistake with my matrix, but I'm not going to worry about that right now. You know, sometimes it's good to have these little shortcuts available to you, because you know we all do make mistakes occasionally. So yeah, I think I made a mistake somewhere in setting up the matrix, but I'm not going to obsess over it right now because we are running out of time and this video is getting a little too long. But if you're having a problem figuring out the answer to question 11, I recommend that you use NonlinearModelFit in Mathematica. It's a nice shortcut. It's a nice shortcut. You should get the same answer using your matrix. But that's assuming that you set up your matrix correctly. And if you didn't set up your matrix correctly, you're obviously not going to get the right answer. Like here, for example, I have the wrong function. So like f of negative 2 should give me 13. It's not, it's giving me 5, and f of 1 should give me negative 11, but it's giving me negative 13. F of 2 is giving me negative 19, so obviously this is wrong. I mean, this answer is simply, you know, this answer is just way off, okay? It's just way off. This answer should be correct, and we can test it. We can test it. So clear f of x is equal to 2 times x squared plus 6 times x minus 7, okay? And then f of negative 2 should give me 13, and it doesn't. It gives me negative 11, which is so strange. We have 2 times x squared. Oh, this should be a minus 6. Sorry. Look at the minus here. That should be a minus 6. This has to be a minus 6. Sorry about that. Minus 6. Minus 6. So clear f. Let's try this one more time. Okay. F of negative 2 should give me 13. Yes. F of 1 should give me negative 11. F of 2 should also give me negative 11. So these 3 points belong to this function. F of negative 2 gives me 13. F of 1 gives me negative 11. F of 2 gives me negative 11. I simply didn't see the negative sign right over here, guys. There's a minus sign right here. I made that a plus. That should be a minus. That should be a minus, okay? So 2x squared minus 6. There's a minus right over here. Yeah, minus 6x, not plus 6x. Minus 6x, okay? So I didn't see that minus. I put a plus here, but actually this should be minus, right? It should be minus. So 2x squared minus 6x minus 7, and we know it works. Because if we define our function, f of x is equal to 2x squared minus 6x minus 7, we just plug in the x values and we can see that we get the right y values, right? So f of negative 2 gives me 13. F of 1 gives me negative 11. F of 2 gives me negative 11. So this problem was a little bit of a headache. I probably entered something incorrectly into my matrix, and that's why it didn't work. But like I said, if you have an issue, you have the function NonlinearModelFit in Mathematica, and that does help you out tremendously. It's a nice help. Remember, the function is NonlinearModelFit. This L is not capitalized, it's a lowercase l. Mathematica, by the way, in case you haven't figured it out, Mathematica is case sensitive. There's a difference between uppercase letters and lowercase letters in Mathematica. All right, now let's see if this is the answer that Pearson wants. Check answer, your input is correct. Okay, we spent a lot of time on that problem. Wow, okay. So that looks good. And I'm going to submit my quiz. And it looks fantastic, okay? So that's your quiz. None of it was really that bad. I thought question 11 was a little tricky, but I must have made a mistake in entering the numbers for my matrix. So right now I'm not gonna worry about it too much, okay? Because this video has gotten a little bit too long. All right, guys, that's it for now. And good luck with your quiz. I'm going to post your, excuse me, I'm going to post your test on matrices and systems of equations sometime later today or maybe tomorrow. Okay, sometime later today. This is Sunday. Today is Sunday, March 28th. Your test will be posted sometime later today, maybe on Monday the 29th. All right, and I'm not going to post a video for that because your test is actually going to be very similar to your quiz. Almost identical, just more questions, more problems, okay? All right, that's it. Take care and have a wonderful day. Enjoy the rest of your weekend. Enjoy the rest of your week. Take care and bye-bye.